वेलकम स्टूडेंट्स, हम डिस्कस कर रहे हैं दी एथ न्यूमेरिकल फ्रॉम दी चैप्टर मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड. सो लेट्स स्टार्ट. So let's discuss the question first. So question says a composite wire is prepared by joining a tungsten wire and a steel wire end to end. Both the wires, that is the tungsten and the steel wires, have the same length and the same area of cross section. So if this composite wire is suspended to a rigid support and a force is applied to its free end, then it gets extended. So the composite wire gets extended by 3.25 millimeters. Calculate the increase in the length of tungsten wires and steel wires separately. Given is the Young's modulus for the material steel as 2 into 10 raised to 11 Newton meter square, and the Young's modulus for the material tungsten as 3.40 into 10 raised to 8 Newton meter square as well. तो क्वेश्चन को पहले हम एक डायग्राम के साथ समझेंगे. हमारे पास एक कॉम्पोजिट वायर है, दैट इज अ वायर विच इज मेड बाय जॉइनिंग टू वायर्स. द फर्स्ट हाफ ऑफ आवर कॉम्पोजिट वायर इज सेड टू बी of a tungsten material. So the first half is a tungsten wire made up of material tungsten, and the second half of the wire is made up of a different material, and this material is said to be a steel material. ठीक है, so steel wire और tungsten wire दोनों end to end connected है. मतलब tungsten का bottommost end is connected to the topmost end of the steel wire. Also keep in mind, tungsten wire का जो length है that is equivalent to the length of the steel wire, and tungsten wire का जो cross sectional area है that is also equivalent to the steel wire का cross sectional area. ठीक है, so ऐसा कुछ हमारा composite या total wire बना हुआ है. अब हम हमारे composite wire को एक rigid support से attach कर रहे हैं, and उसका जो free end है that is its bottommost end, उस पर हम एक force introduce कर रहे हैं. Now because of this force, हमें पता है कि wire will undergo some stress, and because of this stress it will experience some increase in length. So let's say अब wire का increase ले, so this was the wire's original length and this is the wire's increased length. This increase is given to us in the question, and let me mark this as delta L total. So that is the total increase in the wire. But इसी के साथ क्या हो रहा है कि since हमारा wire is made up of two different materials, वो दोनों इंडिविजुअल वायर्स भी अपना कुछ एक्सटेंशन बनाएंगे. So tungsten wire will have some increase in its length, and let's mark that increase as delta LT. Similarly, steel wire will also undergo some increase in its length, and let us mark that increase as delta LS. And यही दो इंडिविजुअल एक्सटेंशंस हमें ढूंढने हैं. So क्वेश्चन में बोला है कैलकुलेट द इंक्रीज इन द लेंथ ऑफ टंगस्टन वायर एंड स्टील वायर सेपरेटली. So हमारा टू फाइंड सेक्शन हमें क्लियर है. अब लेट्स क्विकली फिगर आउट द गिवन सेक्शन एज वेल. द फर्स्ट स्टेटमेंट जो हमें गिवन है दैट इज द टोटल एक्सटेंशन. सो डेल्टा एल total extension is said to be 3.25 millimeters, and we know that this total extension is nothing but the resultant of the individual extension in tungsten wire plus the individual extension in the steel wire, and this is 3.25 millimeters as well. So this is the first quantity that's given to us. Now I know generally हम millimeters को meters में convert करेंगे as a SI unit trick, but for this particular question it actually makes much more simpler calculation if we keep the values in millimeters only. So we're gonna keep the values in millimeters only. ठीक है? And then the second and third quantity जो हमें given है, that is the Young's modulus for the material steel Y of S, 2 into 10 raised to 11 Newton meter square is the value. And the similarly third quantity is the Y of T, that is Young's modulus for tungsten. The value is 3.40 into 10 raised to 8 Newton meter square as well. And we already know the quantities which we are required to calculate. First is the change in the tungsten wire, so delta LT is what we have to find, and second is the change in the length of steel wire, delta LS. So this is what we have to find, increase or change. ठीक है, so to find clear है, given section clear है. Let's try to understand what sort of formulas we can use. So the last formula which we recall, जहाँ पर हमने Young's modulus और delta S देखा था, that was the formula to calculate Young's modulus for a material. It is said to be force into its original length divided by cross sectional area into the change in length or deformation. So this is the formula to calculate Young's modulus. But if you see our question, Young's modulus given hai, delta L ढूंढना है. So let's try to rearrange this formula so that we get a better formula to calculate delta L directly. So I'll just quickly write, we are rearranging the formula. कुछ changes नहीं कर रहे हैं, बस उसे एक better formula में rearrange कर रहे हैं. So the better formula is where we get delta L as F into L divided by A into Y. So Y was at numerator in LHS goes to denominator in RHS, delta L denominator in RHS goes to numerator in LHS. So एक simple rearrangement कर दिया है. Now this formula, if you see, is much more better and capable of fetching us the value for delta L less and delta T. Apart from this, question specifically mentions कि the force applied on both the wires, the length of both the wires and area of cross section for both the wires is same. So F, L and A for both the wires are same. So whatever increase in length that each wire is experiencing, that is only dependent now on the Young's modulus of these wires. So delta L is inversely proportional to Young's modulus. So this now becomes an interesting condition which will help us to simplify our calculation even further. So calculation mein I'll quickly write from condition 3, I can say that the extension in tungsten wire is inversely proportional to the y of t, that is Young's modulus of tungsten. And let me mark this as equation number 1. And the extension in steel wire must be dependent upon its Young's modulus, so it is inversely proportional to y of s. Let me mark this as our equation number 2. And now I can say from equation 1 and 2, I can say, or we can say, that delta LT divided by delta LS, S must be equal to y of S divided by y of T. Therefore, from this, I can say that extension in tungsten delta LT is y of S divided by y of T times delta LS, that is extension in steel. हमको y of s और y of t का वैल्यू दिया है, so let's substitute. Y of s is 2 into 10 raised to 11 and y of t is 3.4 into 10 raised to 8. And let's complete the term, that is into delta ls. So let's do some cancellation. 10 raised to 11 divided by 10 raised to 8 gives us 10 raised to 3. And 10 raised to 3 in 10 raised to 3 into 2 gives us 2000. So this is 2000 divided by 3.4 times delta ls. इसको और simplify कर सकते हैं. If we divide 2000 by 2, we get 1000. And we divide 3.4 by 2, we get 1.7 times delta ls. And now you'll have to use logs to calculate this. So use logs for calculation, but for video, we'll skip the step and we get the answer as 588.24 times delta ls. So if you want to find the value of delta LT, that is extension in tungsten, we'll have to find the value of delta ls first. So let me mark this as equation number 3. And also, we have one more equation from given statement. Also, we know that when we add delta ls plus delta lt, we get 3.25 millimeters. That is the total extension. So let me mark that as equation number 4, which is given to us. So if you see, this was our given equation. Now let's see what we can do. So हमारे पास दो equations है. We have first equation and second equation, and हमारे पास दो unknown variables है. So let's try to simultaneously solve these two equations to find the value of delta LT and delta LS. So what we'll do now, equation 4 may we'll substitute the value of delta LT as 588.24 times delta LS. So I say substituting equation 3 in 4, we get delta LS plus 588.24 times delta LS, that is the value of delta LT, is equal to 3.25 millimeters. You have to always mention millimeters because as I said we are not converting it, so we have to be very very careful कि हम millimeters में ही calculation कर रहे हैं. Now let's add these two terms together. So first let me take delta S common from these two terms. So it is 1 plus 588.24. So हमने इस टर्म और इस टर्म में से डेल्टा एल एस कॉमन निकाला है. So it gives us 5 plus 1 it gives us 1 plus 588.24, and this whole term is equal to 3.25 millimeters as well. So this gives us delta LS times 589.24 is equal to 3.25 millimeters. So delta LS must be 3.25 divided by 589.24 millimeters. Now you'll have to use logs again because we can't help it. So use logs for further calculations. But for the video, we'll skip the step. And if you were to divide these two terms, you would get the answer as 0.0055 millimeters. So that is the value for the increase in length for steel wire. So delta LS, that is extension in steel wire, is 0.005 millimeters. So our first task of the two tasks, that was to calculate the delta LS, is done. And we can now quickly calculate delta LT as well from equation number 4. So if we say from equation 4 and 5, so if we were to substitute the value of calculated delta S in equation 4, so that is this. So we get delta LS ka value, let's substitute. So 0.0055 plus delta LT is equal to 3.25 millimeters. So we have substituted 5 into 4. So delta LT gives us 3.25 minus 0.0055 millimeters. And finally, we get the value for extension in the tungsten wire as 3.244 millimeters. So this is the increase in length in tungsten wires. And as you can see, steel or tungsten wire ka dono ka increase in length is different because dono ka material is different. If you want a PDF of this solution, make sure you check the description. Have a nice day.